RS-232 is a standard for serial communication transmission of data over long distances that was first introduced in 1962. It was widely used in computer systems, data communications equipment, and various other devices. Here are some key facts about RS-232. Pinout: RS-232 typically uses a 9-pin or 25-pin D-sub connector, with different pins assigned for data transmission and reception, signal ground, and control signals like request to send, RTS, and clear to send, CTS. Signaling: RS-232 uses voltage signaling, with a voltage of +3 to +25 volts indicating a logical 0 and -3 to -25 volts indicating a logical 1. Baud rate: the baud rate of RS-232 is the number of signal changes per second, typically ranging from 110 to 115,200 baud. Cable length: the maximum cable length for RS-232 is around 50 feet, although this can be extended using signal boosters or other devices. Handshaking: RS-232 supports several types of handshaking, including hardware, RTS/CTS, and software, XN/XOF, handshaking, which are used to control the flow of data between devices. Data format: RS-232 supports different data formats, including ASCII and binary formats, and can be used for transmitting text, numeric data, or other types of data. Protocol: RS-232 is a physical layer protocol, meaning it defines the physical characteristics of the transmission medium, but does not specify higher-level protocols such as TCP/IP or Ethernet. RS-232 is an older standard that has largely been replaced by more modern interfaces like USB, Ethernet, and wireless protocols. However, it is still used in some applications where long-distance data communication is required or where compatibility with older systems is important. RS-232 is a physical layer protocol, which means it defines the electrical and mechanical characteristics of the transmission medium, but it does not define higher-level protocols. RS-232 is commonly used with other higher-level protocols like Modbus or SCPI, which define the data formats and communication rules. Here are some examples of data formats and protocols that are commonly used with RS-232. ASCII, American Standard Code for Information Interchange, is a widely used character encoding standard that represents each character as a unique 7-bit binary number. ASCII is often used with RS-232 to transmit text data. Binary data is represented as a sequence of zeros and ones and can be used to transmit numeric data or other types of data that are not represented as text. Binary data can be transmitted using RS-232 by setting the appropriate baud rate and using the appropriate data format. Modbus is a protocol that is commonly used with RS-232 for communication between industrial control systems. Modbus defines a packet structure for transmitting data and specifies functions for reading and writing data. SCPI, Standard Commands for Programmable Instruments, is a standardized command set that is commonly used with RS-232 for communication with scientific instruments. SCPI defines a set of commands for controlling instruments and querying instruments' status. PPP, Point-to-Point Protocol, PPP, is a protocol that is commonly used with RS-232 for dial-up internet connections. PPP defines a protocol for transmitting data over a serial link and provides features like error correction and compression. These are just a few examples of the many different data formats and protocols that can be used with RS-232. The specific data format and protocol used with RS-232 will depend on the application and the devices involved. There are many commonly used RS-232 modules that can be integrated into electronic devices, computers, and other systems. Here are a few examples of commonly used RS-232 modules and their compatibility. UART, Universal Asynchronous Receiver/Transmitter. The UART is a common RS-232 module that is used to convert parallel data to serial data and vice versa. Many microcontrollers have a built-in UART, making it a common choice for embedded systems. MAX232. The MAX232 is a popular RS-232 transceiver chip that can convert TTL or CMOS logic levels to RS-232 voltage levels. It is commonly used in electronic devices like sensors, motor controllers, and other embedded systems. USB to RS-232 converters. USB to RS-232 converters are commonly used to connect RS-232 devices to modern computers that do not have built-in RS-232 ports. These converters typically use a USB interface on one end and an RS-232 connector on the other. RS-232 to Ethernet converters. RS-232 to Ethernet converters are used to connect RS-232 devices to Ethernet networks. These converters typically use a serial interface on one end and an Ethernet connector on the other. Compatibility between RS-232 devices can be an issue, particularly when different devices have different voltage levels or signal timing. To ensure compatibility, it is important to use devices that are designed to work with RS-232 and to configure the devices according to the appropriate signal timing and voltage levels. Some devices may also require special drivers or software to work properly with RS-232. RS-232 has been used for many years and is a widely recognized standard for serial data communication. However, like any technology, it has its advantages and disadvantages. Here are some of the main advantages and disadvantages of RS-232. Advantages. Widely supported. RS-232 is a widely supported standard that has been used in many different applications, including industrial control systems, scientific instruments, and computer systems. Simple and straightforward. RS-232 is a simple and straightforward standard that is easy to implement in hardware and software. Low cost. Because RS-232 is a widely used and standardized standard, hardware and software that support it are generally low cost. Robust. RS-232 is a robust standard that can transmit data over long distances without significant loss or corruption of data. Disadvantages. Limited speed and distance. RS-232 is limited in terms of speed and distance compared to more modern standards like USB, Ethernet, and wireless communication. Limited functionality. RS-232 is a physical layer protocol, which means that it only defines the physical characteristics of the transmission medium. It does not define higher-level protocols like TCP/IP.